Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 3, Section 2, Part 4. And we had previously learned about solving problems with the first law of thermodynamics, and we had figured out that the heat flow out of a system equals the heat flow absorbed by the system, and so we figured out how much heat had been lost by the water cooling down, and then we knew that was the same amount of heat that had been gained by the temperature of by the room itself, and so then we could calculate the change in temperature of the air. Okay, kind of going through, and that is what the book did, was that those amounts of energy are the same, and then solving for that, they got 0.75 degrees Celsius, just like us. Okay, the last thing we're going to talk about is heat transfer, so please write this down. Heat transfer is the flow of heat energy. So not Q, but how much, where it's going. So one type is conduction. It is the flow of heat energy through the direct contact of matter. So when my bottom is sitting on some metal football bleachers, heat is going from my body into the metal bleachers. Direct contact. So all materials conduct heat, some quickly and some easily, others slowly and with a lot of resistance. And this depends on quite a few factors. So I want you to come up with an example of a thermal conductor, something that conducts heat easily, and then something that is bad at conducting heat. It's so bad that it is considered an insulator. I want you to come up with another example of that. Okay, so let's look at this. If I have a chunk of metal, let's say, at 100 degrees Celsius, and I put it right next to a chunk of metal at 0 degrees Celsius, the heat is going to transfer from the hotter one to the cooler one through direct contact. So now you need to make a prediction in your notebook. Would you describe the glass of the test tube as a thermal conductor or a thermal insulator? And what you know is that a couple minutes have gone by, and the cold substance was at 10 degrees in a hot water bath at 70 degrees, and now a couple minutes later the cold substance is at 60 degrees and the hot water is cooled down to 60 degrees. So is that a thermal conductor or thermal insulator? Styrofoam. Would you consider styrofoam a thermal conductor or a thermal insulator? So please write your prediction down. And that wraps up our 3.2, and on our next video we're going to talk about the third section, phase changes. We'll see you then. Bye.